3, 2, adding and subtracting and multiplying polynomials. So our objective is that we can do all of those things. So first of all, we need to talk about what are like terms. So like terms means that they have the exact same variables, so the same letters with the exact same exponents. So when they are alike, that means they're exactly alike. The numbers in the front don't matter, but if I have x cubed y squared, I'm looking for other x cubed y squareds. Now, they can be in a different order. They could be y squared x cubed. That is actually the same because multiplication is commutative, and I can rewrite that as x cubed y squared. But the letters have to be the same and the variables have to be the same. And when they are, I add the numbers that are in front or I subtract them depending on the sign. So let's check out this first one on A. We are going to add, because that's what it says in between the two parentheses. So I am looking for other x to the fourths, and I have another one over here. So 4 plus 9 is 13x to the fourth. So my variables do not change. I am just combining like terms. So now I have a negative 3x squared, and I don't have a 3x squared over here, but I am noticing that I have a plus 7x to the third. So I'm going to put that next because that's my next to the highest exponent. And then I will come back and get the negative 3x squared. All right, so those do not have matches, so I'm going to mark those off. Now I'm looking at the x terms, so I have plus 8x and minus 3x, which is plus 5x. And negative 5, last stuff, and positive 6 gives me a positive 1. So this polynomial is in standard form. Highest power is 4, so that's the degree of this polynomial. I have 5 terms, and my leading coefficient is 13. We could talk about the end behavior. My end behavior as x goes to negative infinity, y would be going to positive infinity, and as x goes to positive infinity, y is also going to positive infinity. So they're both going up if I wanted to graph this. All right, so just kind of sneaking back to 3, 1. All right, so let's talk about subtraction. When we subtract, we can change subtraction to addition by leaving the first set of parentheses alone. Changing the middle to an addition sign and multiplying everything in the parentheses by a negative 1. So that means I'm going to change the signs of everything in here to the opposite of what they were. So I have negative 4, I have a positive 5ab squared, and a negative 7a squared b squared. Now I'm going to combine like terms. So I'm looking for a squared b cubed, and I see a squared b cubed here. So I'm going to now add the numbers that are in front. And so that would be 2a squared b cubed. So I'll mark those out. All right, let's look for ab squared. And I have a positive 4 and a positive 5. That makes a positive 9ab squared. And then my last terms also match. So I have a squared b squared, a squared b squared. They are both negative. I have a negative 11 and a negative 7, which makes negative 18 a squared b squared. All right, how do we multiply polynomials? When we multiply polynomials, we use the distributive property. So I have 3 terms multiplied by 2 terms. So I am going to multiply the 6p squared through that set of parentheses. When I multiply, I add my exponents that are alike. So if my exponents are if my bases are the same, if my letters are the same, I'm going to add my exponents. All right, so look at the variables, both p and p. So I'm going to add my exponents. I'm going to multiply the numbers that are in front. So 6 times 3 is 18. p to the third because I had p squared plus p to the first. So p squared times p to the first means p to the 2 plus 1, which is p to the third. All right, and then I have 6p squared multiplied by a negative 1/2, which would be negative 3p squared. All right, so that one's done. So now we are going to take 5p and multiply that, negative 5p. So that makes negative 15p squared, because I had p to the first times p to the first, add my exponents, negative 5 times negative 1/2. So negative 5p times negative 1/2 makes a positive 5 times 1/2. I put 5 over 1, and that makes, multiplying straight across, 5 over 2p. All right, so that one's done. Now let's take the 9 and multiply it through. So 9 multiplied by 3p is 27p, and 9 multiplied by negative 1/2 is negative 9 over 2. And now we want to look to see if we have common terms. So I see we have p squared, and then we have these two terms that have p. So 18p to the third does not have a match. These two are matched, so negative 18p squared. These two are a match, so this is 2.5. So 29.5p minus, you can change it to 4.5 if you want to, or leave it at negative 9/2. Up to you. You can also add these on your calculator. Either way, I'm good with it. All right, last problem. An investor suggests that you split $1,000 between two accounts, a mutual fund and a savings account. The mutual fund pays, we're going to underline that, 4.6% per year. The savings account pays 1.8% per year. Write a polynomial function s of x to represent the interest you'll earn in 1 year by investing x dollars in the fund, so that's the mutual fund, and put the remainder in the savings account. All right, so we have a total of $1,000. We're going to split that between two funds. We have a mutual fund that pays 4.6% per year. So that means however much money I invest, I multiply that by 4.6%, and that's how much money I'll make. The savings account, 1.8% per year. All right, so we don't know how much we're investing, but we know we're investing in these two. All right, so we're investing X dollars in the mutual fund is what they told us. So mutual fund is going to get the X dollars, and then the savings will get, so remember, these two have to add to be 1,000. So 1,000 in the savings, it'll be 1,000 minus whatever was in the mutual fund. So if we put $800 in the mutual fund, the savings would have 1,000 minus 800, which would be 200. So that's what's going into both of those. All right, now we have to figure out how much money we're making, because we want to write a polynomial function to represent the interest. So the interest is going to be the mutual fund multiplied by the percentage that we're going to get out of that. So however much money we invest in the mutual fund, we're going to multiply that by 4.6%, plus however much money we deposit in the savings times 1.8%. Right, so mutual fund savings. All right, so we can clean this up. This would be 0.046x. So remember, when we're changing percentages to decimal, we move the decimal 2 places to the left because we're dividing by 100. So I'm going to do the same thing here. So I would have 1,000 times, I move the decimal twice, 0.018. But when I multiply by 1,000, I get to move the decimal 3 places to the right. So that makes that 18 minus 0.018x. Then you can combine these two together with your calculator, and that will help clean this up. So I will leave that for you to do, and that is my function. They tell me how much I invest in the mutual fund, then I also know how much I will invest in savings. All right, that's it. See you guys soon.